Hi everyone, welcome back to the channel. So today in this video lecture we'll be solving this problem, minimum number of refueling stops. So in this problem we have a car. It travels from a starting position to a destination which is given as target miles, and it is present at the east of the starting position. So there are gas stations along the way which we are traveling. The gas stations are represented as an array stations where each element in this station's array is a pair representing the position of that station and the fuel which can be filled from that station. Okay. Now the first integer is the position, which is basically an integer which represents the number of miles east of the starting position. Now the car starts with an infinite tank of gas. That means we can put any amount of gas into the tank of the car, and which initially has a start fuel liters of fuel in it. So initially we have start fuel liters of fuel in the given gas tank. Now it uses 1 liter of gas per mile that it drives. Now when the car reaches a gas station, it may stop and refuel, transferring all the gas from the station into the car. That means whichever station we are on, will put all of the gas from that station into our tank. Now if we can reach the destination, then we have to return the minimum number of refueling stops the car must make in order to reach its destination. If it is not possible to reach the destination, then we return -1. So let's see how we can solve this problem. Now we are also given that if the car reaches a gas station with a 0 fuel left, the car can still refuel there. If the car reaches the destination with 0 fuel left, it is still considered to have arrived. Okay, so let's better understand the problem statement using an example. So here we have example. The car is here sitting at the position number 0. The car is here, and initially the fuel that the car tank has is 10 units. Now these are the stops indicated at position number 10, 20, 30, 60. And this is the target position, that is 100. So we want to reach this target position, while these are the intermediate stations where our car can stop. Now initially the tank has 10 units of fuel. So from position number 0 we can travel to position number 10. Okay, and here at position number 10 the tank will be empty, and that means we have to refuel the tank at this position. So we refill the tank at position number 10. Now we have 60 units of fuel in our gas tank. Now from position number 10 we move to position number 20, 30, and even at position number 60 without stopping at any of the intermediate fuel stations that are present at position number 20 and position number 30, because we have the fuel in our car, in our gas tank. So to reach position number 60, we'll consume 60 minus 10, that is 50 units of fuel. Okay, so we consume 50 units of fuel and we are present on this position. From here we still have 40 miles to cover. We have 40 miles to cover, while the remaining gas in our tank is 10 units. And from this station we can fill 40 units of fuel. That means the total fuel that we would have while we depart from this station would be 10 plus 40, that is 50 units. And the number of miles that we have to travel is 40 units. And that means we can always reach our target using this fuel that we have in our tank. So from this position, which is position number 60, refill the tank, getting to a capacity of 50 units. Now we have 50 units of fuel, and now from position number 60 just reach position number 100, and at position number 100 the remaining fuel would be 10 units. Okay, and that means we stopped at exactly 2 gas stations at position number 10 and at position number 60, and the answer for this test case would be 2. Okay, and this is the most optimal way to stop at the gas stations. Although there are other ways, like I can start from position number 0, reach position number 10, refill the tank, then reach position number 20, and at position number 20 again fill the tank. Okay, now here at position number 20 I will have 80 units of fuel, while the remaining distance from 20 to 100 is also 80 units. It is also 80 units. That means I can simply reach the target location without stopping at intermediate gas stations which are present at position number 30 and position number 60. All we had to do is to stop at location number 10 and refill the tank, then stop at location number 20 and refill the tank, having a like net gas capacity of 80 units at this point. Fine, because I had 60 units here, then I traveled 10 units, consumed 10 units of fuel, having 50 units of net fuel in the gas tank, and then refill from this gas station to give us a net fuel of 80 units, while the road to travel is also of 80 miles from 20 to 100 position, and this is another way to reach the target. Fine, so let's take one more way, which is this in this way. If I like reach the target in this way, then in this case I will again consume 2 gas stations. Now there are multiple ways, and the minimum number of gas stations that I require are 2. I can't go to the target with less than 2 gas stations. I have to stop at 2 gas stations to refill the gas tank. Fine. Now how can I solve this problem? What is the optimal strategy to solve this problem? Just think about the scenario. We want to reach a gas station which is present at this target location and here, and we have some certain amount of initial fuel. Okay, and we don't know, we have no idea which gas station is the most optimal to stop at. Fine. So how can I decide that? Let's say I am present at any position, let's say this position number 50, let's say at this position. How would I decide while I am on position number 50 that from the gas stations which I have came across, that is at position number 10, 20 and 30, which one is to pick up? Fine. So to do so, to decide which gas station is the most optimal to stop at for refueling, is simply the intuition, it is evident that like at any position, let's say here at position number 60, the most optimal, let's say at position number 60, if I want to stop at if I like to reach position number 60, now the solution is simple. Let's say to reach position number 60 here, I have to consume fuel, or I have to stop at one of the intermediate gas stations which are here, one or more intermediate gas stations. Then how would I choose those gas stations out of these 3? How would I choose them? Obviously those gas stations which have greater amount of gas will be chosen. Fine, because if I want to minimize the number of gas stations which I can choose, then I have to choose those gas stations which offers greatest amount of fuel. Fine, that's the strategy. That's the simple strategy to solve this problem. Simply keep track of all the gas stations in some container which orders those gas stations in the increasing order of the fuel that they are offering. Like here in this case, out of these 3 gas stations, the gas station present at position number 10 will be at the top location, will be the top priority. Why? Because let's say I want to reach this location which is 60. Now I already know somehow that I need to refuel out of at least one refueling station which are present at position number 10, 20 and 30. Then the obvious, and it is also given that I can refuel from any of these 3 gas stations. Then the obvious choice would be to choose this one, that is the gas station present at position number 10. Why? Because it offers greatest amount of fuel to our tank. Then the second priority would be gas station at position number 20, and then the gas station at position number 30, or vice versa at 30 and then 20, and they will be ordered like this. Fine. So that's how we're going to solve this problem. To order these gas stations in this order, I will use a priority queue. Fine. So I will simply iterate over this gas station array which contains pairs, like each pair contains the position of a gas station and the fuel that it offers. Now for any gas station, like at any gas station, I will simply find the amount of fuel that has been consumed to arrive at that particular gas station. Now if the fuel that has been utilized or that has to be utilized to reach there is greater than the fuel that we had when we started, then that means I had to stop at one of the intermediate gas stations, and the station where I will stop will be the one which offers the greatest amount of fuel. Fine. So I will simply iterate over the gas stations and I will keep pushing the capacity or the fuel which each gas station is offering. Like here in this case, I will keep a priority queue. I will start from position number 0. I will iterate over all the gas stations which we have. We have 4 gas stations. So for the very first gas station, I will push 60. Okay. Then for the next gas station, and while sitting on gas station located at position number 10, I will count the distance that I have traveled. We can see that the distance that I have traveled to reach gas station at position number 10 would be 10 units, because the previous location is this, which is 0, and the distance from the previous location to the current location is 10 units. Okay. Now that means I have consumed the fuel that I initially had. Okay. Now I will move to the next gas station, which is here, which is present here. I will iterate over this, and here at this gas station I will simply check what is the distance that I have traveled to reach this gas station. It is 20 units, or let's say it is not 20 units, it is 10 units. Why? Because I have traveled 10 units to reach the previous gas stations. Here I have already traveled 10 units to reach the previous gas stations, and I have consumed the fuel which I initially had in our tank. Now to reach position 20, I will require 10 units of fuel. I will require 10 units of fuel, and that means, and initially we just had 10 units of fuel, and to reach at 20th position I require extra 10 units, and that means that extra 10 units has to be arranged from somewhere, which will be taken from the intermediate stations which is present in between the way, before position number 20 and after position number 0. Now out of all those intermediate stations, which is like I just have only one of them, I will choose the one which offers the greatest amount of fuel. And we can see that we just have 60. So I will use this 60 and I will simply make up for the fuel which is used to reach at position number 20. So at position number 20 I will have 50 units of fuel left. Okay, so the current fuel is 50 units. Now iterate over the next gas station, which is this gas station. Okay, before that push this fuel which the gas station at position number 20 is offering. So push 30 into the priority queue. Now arrive at the third gas station here. Now to reach the third gas station, the distance that I have to travel would be 10 units. Okay, the distance is 10 units, and simply subtract this distance from the current fuel that I have. I have 50 units of fuel, and after traveling 10 units I will have 40 units of fuel. Now at gas station at position number 30 I have stopped at one gas station, like I have consumed fuel from one gas station which was present at position number 10, and the remaining fuel that I have at position number 30 is 40 units. Okay, now reach the last target, finally reach the target because we have traversed all of the gas stations. Now while leaving this gas station, push the fuel that it is offering into the priority queue. Now I have two gas stations into the priority queue where I could stop. Now move to the target. The position of the target is 100, and to reach at the target position I have to travel 100 minus the position of the last gas station which I left, which is 30. That means 70 units. I have to travel 70 miles, and the fuel that I had when I departed from gas station present at position number 30 was 40 units. That means the extra fuel which I require would be 70 minus 40, that is 30 units, and this fuel had to be taken somewhere from one of the gas stations which I have in this priority queue, or which I have traveled, or which I have passed through but haven't consumed the fuels from. So out of these gas stations I will pick the one from the top, because that gas station that is present at the top offers the maximum amount of fuel. Okay, now pick up the 30 units, and definitely those 30 units will make up for these 30 miles which I have to travel. That means out of these three gas stations, choose the first one present at position number 10, and then choose one of these gas stations. Choose any one from these two, and that will do our job. We'll reach at the target, and the answer would be 1 plus 1, 2, because these are the number of gas stations which I had to stop. Now the answer would simply be the number of gas stations or the number of elements which I am popping from the priority queue. Okay, and that would be my answer. In this case the answer is 2. So let's see how we can implement the strategy, how we can implement the idea. So if you got the explanation, then the implementation is really simple. All we had to do is just create a function min refuel stops. It is the target location where I want to reach. This is the tank or the initial fuel which I have while I'm starting from position number 0. Here is the stations array, which contains a pair of integers where each pair represents the position of the station and the fuel that the station offers. Then I have two variables, answer variable initialized to 0, previous variable initialized to 0. Then I declare a priority queue, and then I'm iterating over the gas stations. And for each gas station, extract the location and the fuel that it offers, and simply subtract the distance that I have to travel to reach at the current location. And this previous variable is used to maintain the previous location, so that I can always remember or count or find the last moved distance. Okay, or the last traveled distance. Like here in this case, the current location is this, the first element in this station's array in this current pair, while the previous location is given by this previous variable, and the difference between the current location and the previous location will give me the distance which I have traveled to reach this location, and that distance is equal to the fuel that I have consumed, and this tank represents the fuel that I currently have in the tank. And simply to reach at the current location, I have to use the fuel equal to the difference between the current location and the previous location. Fine. So after subtracting this value from the tank, I will have the remaining fuel in the tank. Now I will simply iterate over the priority queue. And why? Because probably I have consumed all of the fuel of the tank, or this tank variable may go negative. If it goes negative, that means between this previous location and the current location, I had to stop at one of the intermediate gas stations to refill our tank. So here simply keep adding the elements from the top of the priority queue till our tank variable is negative. Okay. If it is negative, that simply means I had to stop at one of the intermediate stations to refill our tank, and that intermediate station is chosen wisely according to the fuel that they are offering. That is, the station which offers the greatest amount of fuel will be prioritized first, and that's why I'm using a max heap. Okay, and simply keep popping the element, and the number of elements which I am popping from the priority queue will be simply the number of gas stations where I am stopping to refill our tank, and that will be counted as my answer. So in this fashion, I will iterate over every gas station and repeat this procedure. Like at any point after consuming all the stations, or after, like, there can be a scenario where even after refilling at every station, I am unable to reach the location. How would I check that? Simply by this condition. This condition states that if the tank is negative, that means even after consuming the gas from all of the intermediate stations, I am unable to make up for the distance. Okay, I am unable to make up for this distance, location minus previous, and that means I will never reach this gas station or this current location, and so I return -1 right from there. Otherwise, I will reach the current location, and now I am leaving this location. That's why this previous variable will be reinitialized to this current location, and I will push the fuel that this gas station is offering for further use into the priority queue. Okay, so in this fashion I will iterate over all of the gas stations, and at the end, when I'm done with iterating all of the gas stations, I just had to reach the target. So this previous will here store the location of the last gas station which I left, and this is the destination location, and the distance that I have to still travel would be target minus previous, and that will simply be equal to the fuel which I require in my gas tank, and that's why I will subtract this fuel from the tank which I have. Now again repeat the same step, iterate over the priority queue till the priority queue is not empty, and I forgot to mention this condition, that is till this priority queue is not empty and the tank is negative, the tank variable is negative. That means I had to refill my tank at one of the intermediate gas stations which I have pushed into this priority queue, and I will keep doing it until I will make up for the difference which I have here. I will make up for the fuel which is consumed to reach the destination target, and that will also be counted as the answer, because that simply represents the number of gas stations which I have to stop to reach the target. Fine. And at the end here, when I am done reaching my target, I will check if I can reach the target or not, because if the tank is negative, that means even after consuming all of the intermediate gas stations, that is the fuel from all of the intermediate gas stations, I am unable to reach the target, and in this case I will return -1. Otherwise, I was able to arrive at the target location, and in that case I will return the answer, which represents the number of gas stations which I had to stop to reach the target location. Fine. So in this fashion this algorithm is working. I hope you got this code line by line, and just try to absorb this algorithm, how priority queue is used to solve this problem, because there are a lot of patterns which are based on this problem. Okay, so let's just jump to the code implementation part. So this is the min refuel stops function. In this min refuel stops function, I will declare two variables: answer, which represents the number of stops where I refill my tank, and a previous variable which will be used to store the previous location. Now declare a priority queue. It is a max heap. Now iterate over all of the gas locations, iterate over the stations array. Now the first element is the location, so station 0 is the location, and the second element is the fuel that it require, or the fuel that it offers, station 1. Now calculate the distance which I have to travel, that would be simply, let's call it D. So D is nothing but the current location minus the previous location. Now subtract this distance from the tank, because this distance is simply equal to the fuel which I consume to reach at the current location starting from the previous location. Now iterate over the priority queue till the priority queue is not empty and my tank is negative. That means if the tank is negative, means I have to consume the fuel at one of the intermediate locations, and simply add the top element from the given priority queue, and keep popping out the element and counting the number of stations where I have stopped. Finally check if the tank is still negative. If the tank is still negative, that means even after stopping at every intermediate gas station and refilling from there, I was unable to make up for the distance. So from here return -1, that means I will never be able to reach this current location on which I am standing. Then that means I was able to reach this current location, and in this case I will push the current fuel into the priority queue. Okay, and that's all. In this fashion I will traverse all of the gas stations, and at the end I want to reach the target. So subtract the distance from the last location or the last gas station till the target or the destination target, and the distance would be target minus the previous. Finally I have to travel this much distance. Now subtract this distance from the tank variable and check if the tank is negative. So while priority queue is not empty, and the tank is negative, in that case keep refilling the tank at one of the intermediate gas stations and keep popping out the element and counting the number of gas stations where I had stopped, and after that check if at ending position, that if the tank is negative, that means at the final position at the target, check if I have consumed the entire, if even after consuming fuel from all of the intermediate gas stations I was unable to reach the target gas station. So in this case return -1, otherwise return the answer. Fine. So let's just run this code. It is giving me wrong answer for this case. I don't know. Okay, I forgot to update. Okay, I forgot to update this previous location. The current location will become the previous location when I am departing from here. Now let's again run. Okay, it got accepted. Let's submit it. Okay, that got accepted. So here I'm iterating over all of the gas stations. There are n gas stations, and here we can see that in this while loop I'm using a top operation and a pop operation. So this is a pop operation, and that means we know that if we have, let's say, n elements in the priority queue, then the pop operation requires log of n time complexity. Okay, like here I'm adding the fuel which the intermediate gas stations are offering. Okay, now here in this case, we can see that the push pop operation for the priority queue consumes log of n time complexity, and that would be my overall time complexity, which is n log n. Fine, log n for the priority queue and n for iterating over the gas stations. The space complexity is big O of n because I'm using a priority queue here, or a max heap. Fine, so this is one of the approaches to solve this problem, and this is the most optimal approach. There is another approach to solve this problem which uses dynamic programming strategy, and the time complexity for that approach is big O of n square. That is a suboptimal approach, but we'll discuss that approach in the next video. So that's all for this video, and I hope you enjoyed this video.